Okay, so if you take a look at the function called add, so the arguments would include the PTR, which is our pointer, and the number of rows and the number of columns. So looking at our function add here, so the parameters that it has would also include a pointer, which will receive the address stored in PTR, and the number of rows and the number of columns. Okay, then since it's a two-dimensional array, we need a nested for loop. So again, the outer loop is for the row counter and the inner loop is for the column counter. Then to access the actual elements, we follow the same syntax such as here, but we attach the dereferencing operator. Okay, so here we use our parameter p, which basically contains the address stored in PTR here, and add it with the current row multiplied by the total number of columns plus the current column number. Okay, then for each iteration, I and j will change, and whatever the value of s is, the last value that will be returned to the caller and replace this function call. Okay, so again, for a two-dimensional dynamic array, just simply follow this syntax. So the pointer plus the row number times the total number of columns plus the column number. Okay, so to access the address, we do not need the dereferencing operator, but to access the actual element, we need a dereferencing operator. Okay, then aside from malloc, we can also use calloc to request memory from the heap. So it's another function for runtime storage allocation. The only difference between malloc and calloc is that calloc expects two arguments. First is the number of storage cells to be allocated, and second, the size of each cell using size-up operator. Okay, so for example, this is how we use calloc. So here we declare a pointer variable, which is a pointer to an integer, and using calloc, if we want to allocate 20 cells of 2 bytes of memory each, which is the size of our integer, we just separate it with a comma. So if this is malloc, we use the multiplication operator and we multiply 20 times size of int. But if you're using calloc, we just use a comma to separate the two arguments. So 20 here is the number of storage cells, and the size of int is the size of each cell. So all in all, you have 40 bytes of memory here. Okay, then it's also ideal to include a checking portion in your code. So to include checking, this is how we do it. So we just put it in an if condition. We test whether PTR is not equal to null. If PTR is not equal to null, then we can proceed with our usual processing. Otherwise, if PTR is equal to null, then our request cannot be satisfied, meaning to say we do not have enough memory that will be allocated from the heap. Okay, so in short, you have two choices, malloc or calloc, if you want to allocate memory from the heap. Now, if you're finished using the memory allocation, you need to return that so that you can avoid having a memory overflow or memory shortage, or you can have the same memory space as before. So we need to use free, the function free, which is the function for releasing runtime storage, which will return the previous memory allocated to your heap. So free expects only one argument, and that is the pointer that is currently pointing to the storage currently allocated from the heap. Okay, so to use free, so for example, using malloc, so PTR here, let's say, points to a valid address in our heap. So if you already finished using that memory and we do not need it anymore, so to release it and to return it to the heap, this is how we use it. So we just simply invoke free and put PTR as our argument. Okay, so that ends our discussion about pointers. So if you have questions, just feel free to email using our Yahoo groups. So tomorrow you can ask questions about any clarifications as to the lecture that we have today, and I will also be discussing the answers to the long test that we had. Okay, thank you.